All right, 6-2. Graphs of functions. So, a couple things going on in here today. 6-1 kind of introduced us to the concept of a function. Officially, it's written this way, and then I could have x plus 2 or whatever the function actually is there. And we set our x values, whatever comes out, that's our output there, our y value, f of x. I mean, for all purposes at the moment here, if you like to just think about it this way, instead of writing f of x all over the place, if you just want to call it y, I won't get upset about that. But again, it can help because you know that if x is 1, y is 3. And of course, that's a coordinate right there that I could plot on my graph and things like that there. But they'll be giving us some of these input outputs. So let's look at number 3. And it says input x, and then over here it says output. And they're calling it f of x, but we know that's the same thing as y. Domains and ranges, inputs, outputs. So they're saying here, I got an input of -3, -2, -1, an output of -4, -3, and -2. So what they're saying here is they're saying a function exists between x and f of x there, and all 4 orders of operation are in play here. Adding, subtracting, multiplying, and dividing. What we're trying to do is figure out the rule, or figure out the rule that makes all of these true. So I guess my question to you is, if I started at 3, -3, and ended at -4, how did I get there? I subtracted 1 from the value, so I could say my f of x here equals whatever x was, in this case -3, and then I just subtract 1 from it, and I would get a -4. So does that rule work for this one? Yeah, because again, I started at -2, subtract 1 from it, I get -3 as my output. Does it work for here? Yeah. So this would be my rule. I could certainly write it this way if you really wanted. I don't really think you'd want to, but both of these are okay, I suppose. So, right. Again, if you use your f of x, all the power to you. If you use y equals, I'm not too bad out of shape. The part I'm most interested to see for your answer is this part right here, though. That's what I would want to see for this one here. Let's try number 5. So, input, output, and this time -2 to -1, 0 to 0, and 2 to 1. And I mean, honestly, I usually start with my adding and subtracting first here. So to go from -2 to -1, what did I do? I added 1. So I could basically say my f of x is wherever I started, and then I add 1 to it, and it works, right? So now, if I apply it here, well, what happens this time? Right, because if I plug in a 0 to this function here, 0 plus 1 is 1, not 0, right? So this tells me... So anyway, f of x, x plus 1, it certainly did solve the first part there, but the problem was when we went to the second part here, it does not no longer make it true, which means this is not the correct function. So back we go again. We've tried adding plus 1. What is another way I could get from -2 to -1? Not adding or subtracting. I'm at -2. Now I'm at -1. So what did I do? Well, I didn't multiply because that would be like 2 to 4. I divided. What did I divide by? If I divided by -2, I would have a positive 1 out here. So we could try that. F of x, so wherever I started, and then divide by +2. So -2 divided by +2, odd number of negatives, -1. What is 0 divided by 2? Right, anything divided by 0 itself. And then what's +2 divided by +2? Right. So this time my function was f of x equals x divided by 2. And that's why you have to test your rule on all three of them there, because again, you can always make a rule for just one thing. But the question is, if it truly is the rule, it has to make all three of them true. It has to make all three of them true. Try number 7. Input x, output f of x, -2, +12, -1, +11, and 0, 10. And this one is a little more challenging. So when you're doing these here, and again, we're so wired to, especially in our middle school minds, we always see x in the front. That is not necessarily always how it is, because if I try and do x, whatever it is, and then do something to it, such as multiplying by -6, well, that doesn't work here. Adding a +14 doesn't work here either. So there's really nothing I can do to x here. So then what happens is, try moving, instead of being in the first spot, what if x was over here? So think of a number, any number, such as, we'll say 5. Okay? And then, what am I doing to x? We'll just say, subtracting it, subtract x. So if I have 5 minus -2,
Shoot, that's study hall right now.
huh?
Shoot,
Oh,
study
right
hall
now.
right now.
Yeah, it's right on my right corner there, I think right on top, over there, right?
This one.
I think that's it. Yep, Savannah's there. Yep, that's the one.
Thank you.
Yep, thanks, Vicky. So if I do 5 minus -2, what do I get? Right, +7, okay. Let's try 8. Well, what's 8 minus -2? 10, closer. Let's try 10. What's 10 minus -2? Okay. What's 10 minus -1? What's 10 minus 0? So then my f of x, we found it here, equals 10, subtract x. Whatever x is, I'm subtracting it from 10 here. You won't see many like this, I promise you here. I don't even know, I'll have to check the quiz. There'll be a few in the homework here, but they're showcasing here that, again, it's not a law that X is always gonna be in that first spot. Now, it's a lot easier when it is, like 3 and 5 were for us. They were quite a bit easier when I could just think, and then what could I do to X? But 7 here is showing us that here instead, we're going backwards and we're applying the rule to X this time, not a constant. So, little mind bendy. Again, if you're going through and thinking times 6, no, plus, no, none of those things work there, then we can consider something else. All right, number 9, or not number 9. I want to look at number 11 here. And once again, if we kind of roll through the bases here. Okay. And again, the first things I'm trying to run for first are my adding and subtracting. So I was at -2, I ended up at -7. What did I do? Yeah, I took X and I subtracted 5. So then if I plug it in here, plug 0 in, which output should I get? If X is 0. Well, it would be -5, but I got -1, which means that is not the rule. So now I can consider multiplying. So what did I multiply by from -2 to -7? 3.5. So 3 1/2 X. Okay. So if X is 0 and I multiply it by 3 1/2, what do I get? So that's not the rule either, is it? So what do we got left here? Well, two-step equations, right? Kind of like what we saw. What is that for? So let's take another step back here and try this again. When I've tried my subtraction, tried my multiplying, and neither work, then most likely there's 2 orders of operation going on here. So let's try this. What if I would multiply this by 3 first, and then what would I want to do? Not add 1. Subtract 1, because 3 times -2 would be -6. -6 minus 1, there's my -7. So this one here, what's 3 times 0? Minus 1. 3 times 2? Minus 1. There's my rule for that one here. A two-step type equation. They're a little wonky. I won't dispute that with you. I'll give you a couple more. We don't have 2 more. Well, I'll give you 1 more to try. Then we got to move on here. Dumb fire drill. And again, I'll tell you again. So let's see what you can do with this. Input, output. And this time I'll say 1, 4, 2, 6, 3, 8. So if I'm looking at it here again, I'm just trying to apply a rule to here. I try my addition first. X plus 3 makes sense, but if I add 3 to 2, I get 5, not 6. So x plus 3 is a no-go. So the next thing I'd probably try is, well, times 4. Whatever x is times 4, but when I go 2 times 4, I get 8. So once I've eliminated the adding and subtracting and the multiplying and dividing, I should realize this is probably a two-step thing. So how else could I get to 4? I could multiply by 3 equals x times 3. So 1 times 3 is 3, and then I could add 1 to it, right? So then 3 times 2 is 6. 6 plus 1 is 7. So this is not the rule here either. So how else could I get there? Well, I could say, okay, well, what if I multiply by 2? So 1 times 2 is 2, and then 2 plus 2 is 4. And then over here, plug it in, 2. 2 times 2 is 4. 4 plus 2 is 6. 3 times 2 is 6. 6 plus 2 is 8. There would be my rule for that one right there, 2x plus 2. So, you know, on your quiz and test, I believe how I wrote it is I ask you one that's more like this, kind of a one-step, fill in the blank, and then you'll see one that'll probably be like a two-step thing here. There's some trial and error involved in here, but I still recommend going through, check your x's first. If that's not work, or check your add, subtract first. If that doesn't work, try your multiply and divide. If that doesn't work, then start thinking of combinations of the two. And again, once I realized times 4 and plus 3 were no good, really all I had left is times 3 times 2. There's really no other combination I could get with the numbers I have provided here. So this would be it. Kind of stumbled upon it there. I think you understand it, how it works. You're just trying to identify the rule that's in play. There is always a rule in all these here. The question is, what is it? That's what you're figuring out. You're kind of going backwards with it. Make sense? Backside. So now, here we go. This will be your first opportunity on a separate sheet of graph paper. Make a table of values for each function. Then graph the solution of the function. So number 13. And again, I'm going to make some with graphs, some without here. Number 13 says y equals x plus 1. And it wants us to make a graph and a table of values. So now we already know the function. Cool. And what we're trying to do is we're making our own table here now. We can identify the values ourselves. Our x coordinates, plug them in, that'll give us a y. Put it out here. So when you do these here, you want pretty much 3 points. 3 points is going to be the magic key throughout all this chapter here, because 1 point, you can't make a line. 2 points, you can make a line, you know, with 2 points anywhere. But 3 points, remember, you're always going to get a straight line. So 3 points, 2 points, if you got it wrong, you'll never know because you can connect any 2 points together. But can you draw a line through 3 points? And if you can make a straight line through all 3 of them, you can feel pretty good that you got the right answer. If you put your 3 points out there and, you know, one of the points is not forming a line or you can't make one straight line, then you don't have the right solution. So 3 points is the magic number because 2 points, any 2 points, I could go here and here or here and there or there, you know, they all could make a line, 2 points. But can you make a line with 3 points? So all these things here, you're going to want 3 points. You're always going to want 3 x values that you decide. So the first thing I do is just make a little table off to the side, x and y. And I will pick my x values, whatever I want them to be. Usually I keep them pretty small. So, because again, I have to graph this thing here. So I'll just say -2, 0, and +2. Sounds good to me. And now I'm going to go through and plug each of them in here. So negative 2, if x is negative 2 plus 1, y would be negative 1. If x is 0, and I add 1 to it, I get a positive 1. And if x is 2, add 1 to it, I get a 3. And again, I will leave this up to you to decide what you want to do here. But now I got to head over to the graph. And I'm going to put this one on here just so you can kind of see. Negative 2, negative 1 goes right there. 0, 1 goes right there. And 2, 3 is right there. So I've just graphed my 3 points. Negative 2, this is negative 2, negative 1. This is 0, 1, and this is point 2, 3 right there. Plot your x-coordinate first. This is your x-axis. So whatever your x value is, negative 2, and then your up and down, that's your y value. And again, negative things are going to be below the origin, positives are going to go up. But if I take my ruler and draw a nice straight line, you can see that my line does indeed go through all 3 of those points as it should. If it doesn't, I got a problem here. I don't have a function. But you could, again, we looked at this before, but if you see right here, see how I go through this point right here that I'm pointing at? Well, what point is that? Right there. What point is that I just plotted?
Oh, it's 5.
X value?
4.
Right, so my x value is 4, and then my y value is 5, 4, 5. If I go back to the equation and plug in x is 4, is y 5? Yeah. And that will be true for any point. I could go down here, I got negative, this is negative 5, negative 4 right here. Negative 5, there's my x value at negative 4. Negative 5 plus positive 1 does equal negative 4. So every single one of these points here would make that my function true. All of them. I have unlimited choices in a way of how many coordinates I want to choose. It's just a matter of you taking your thing, making your own little table, and then graphing it. Try number 15. And this time I'll graph it by hand, but it's not the worst idea. Again, you can use the graph paper if you want. There's stuff on both sides, so you can sometimes share a graph, one thing, like do 2 graphs on one sometimes. It's up to you. I got lots of this paper here, but graph paper is nice because, again, in using a ruler, I get very precise data here. But try number 15. And we'll have to wrap it up here pretty quick. Y equals 1/2 x. This is basically all of it here. The first half is finding the function rule yourself. What's the rule in play? And then the second half is just graphing. 22 here, again, you can make up your own x values, plug them in, and see which of these graphs make it true. Again, time purposes here, we're almost at overtime, but when I see I'm multiplying by 1/2. So when I'm picking out my numbers here, I want to think of coordinates that are going to be easy to plot. I don't really want to be dealing with fractional points on a line. I mean, it's difficult to, try 1.5 or 2.8. I mean, how are you going to graph that there? So when I see multiplying by 1/2, same thing as like dividing by 2, I'm looking for even values. Because even values, when I divide by 1/2, will give me an even outcome, right? So when I think of x, I'm going to avoid any odd numbers here just because I don't want to get an odd output. If x is 1, y is going to be 0.5. And trying to graph 0.5 is just, it's difficult. So I'm not saying it's impossible, I'm not saying it's wrong, and I'm also not saying you can't do it. But trying to just get whole numbers will make your life a lot easier when you have to graph this stuff. So again, I'd probably just go with -2, 0, and 2. You may have picked something else, but -2 times 1/2 is -1. Anything times 0 is 0. 2 times 1/2 is 1. Now again, I got nice, clean, easy whole numbers. You can certainly just make your own graph off to the side. You want to try and be generally, keep it as best you can here. But you'll need to go through and label. So there I am labeling, and then it's just a matter of -2, -1 is right there. 0, 0, origin point right there, and then 2, 1 is right there. And again, you can do this. I mean, this is fine. I'm not too bent out of shape about it. My line is pretty straight here. For today's lesson, this is fine. But if you're going to sketch them out by hand, you need to, 1, make sure you label, and 2, make sure you have about the same interval between all your points. If you don't, your line's going to get fuzzy looking. If you're doing it on here, again, do I care if you use a ruler the whole way? I do not. So, what were they here? -2, -1, boom. 0, 0, boom, 2, 1, boom. I could just kind of go, as best I can there. That's okay. That's okay. If you don't have a ruler, I'm not too bent out of shape about that today. But, again, if I had a point out here or something, well, that would be a concern. How am I going to draw a line between, a straight line between those 3 points? You can't. That's why 3 points are kind of your magical number here. It's not so many that it's getting excessive. I mean, I don't need 6 dots to make a straight line, but 2 is just not enough, because if I have one here and then my second one was up here, well, that's not the right line at all. If I had here, here, and here, I mean, just did those 2, I would get the wrong. 2 points is not enough to be definitively concluded. 3 is. Okay, I better wrap it up. Cord, you better. Thank you guys.